Hello dear students, welcome to my YouTube channel. In this video we will see inductive effect and its type. There are two kinds of an inductive effect that we will see with an examples. So like the video and subscribe the channel for more updates and more videos. So we will understand firstly the background of an inductive effect. So it involves and sigma electrons. So there are two or three kinds of an electrons, and so one of them it is an sigma electron. See, if there is an carbon-carbon single bond, say suppose this it is an carbon-carbon single bond in between. Bond it is formed due to an two electrons where it has been shared. So we are talking about now an sharing of an electrons which causes an covalent bond. So this covalent bond, and this covalent bond it is like it is said to be an sigma bond because it involves an sigma electron. Sigma electron means there are two electrons, they have been shared from an carbon-carbon last orbit, and it forms an sigma bond. So wherever it is a single bond it will be an sigma. So wherever there will be a double bond between carbon and carbon, so one will be sigma and one will be pi. And whenever there will be a triple bond between carbon and carbon, so 2 will be pi and 1 will be sigma. So here we are talking about an sigma electrons. So sigma bond is formed due to two electrons. So two electrons it is equal to one bond. It is equivalent to one bond. Sigma electrons which forms a covalent bond are not equally shared between the atoms. Earlier in the concept of an bonds we have seen that sigma bonds they are formed due to an sharing of an electrons, but this sharing it is not equal one. When it is not equal one, when there is some kind of an inductive effect it has been shown, at that moment it is not an equally shared. So this is because the atoms have a different electronegativity values, that it is different powers of an attracting electrons in the bond. Consequently, the electrons are displaced towards the more electronegative atom. So we will see further also, like suppose for an example, here it is carbon and chlorine bond. We know that carbon it is more electronegative. So it is more electronegative, and compared to that chlorine, carbon it is less electronegative. So the electronegative power of an chlorine it will attract the electron towards itself. Though this bond it is formed due to sharing of electrons between carbon and chlorine, but the chlorine has an electron attracting power due to which there is shift of an electron towards an chlorine. It means that density of an electron it is shifting towards an chlorine, and it introduces a certain degree of polarity in the bond. When the shifting of an electron it comes to an chlorine, it means that it will have a delta negative charge and this carbon will have a delta positive charge. And why it is having a positive charge? Because electrons are taken away from the carbon towards the chlorine, and that is why it is having a positive charge. The more electronegative atom acquire a small negative charge, and less electronegative atom will acquire a small positive charge. As I have shown over here that carbon it is less electronegative, so it will acquire a charge that is positive, and this chlorine it is electronegative atom and it will have a negative charge. So we will discuss about an carbon chlorine bond. As I have told you that chlorine is more electronegative and it will become negatively charged with respect to an carbon atom. So here it is having a delta positive charge carbon, and here chlorine it is having a delta negative charge. And this arrow it is showing that it is the electrons are flowing towards the chlorine. This arrow it always shows that the electrons are flowing towards the chlorine, and density of an electron towards the chlorine it is higher. So here you can see it is dark towards the chlorine. It means that density of an electron it is higher towards the chlorine. Though it is formed due to sharing of an electrons, but density it is higher on the chlorine side. It means that the polarity it has been formed in an inductive effect. So structure one it indicates an relative charges, so that is delta positive and delta negative. And in the second structure it shows the head arrow placed towards the middle a bond indicating the direction of electrons are been drawn. So this arrow, it is indicating that electrons are been drawn towards the chlorine. And in the third structure, as the heavily shaded path shows the region in which electron density is highest. And now we will come towards an definition of an inductive effect. So this inductive effect, it refers to an polarity. So polarity, I have told you that carbon and chlorine. So carbon and chlorine it is having a delta negative charge, and carbon it is having a delta positive charge. So polarity is produced in a molecule as a result of higher electronegativity of one of an atom compared to another. Here the electronegativity of an chlorine, it is higher, and due to which the electrons are moving towards the chlorine. So this polarity is said to be an inductive effect, where there is not an equal electronegativity between two atoms. So one, it is more electronegative, and another it is less electronegative. So there is a shift of an electrons, or density of electron, it increases on an atom which is having an electronegativity higher. Atoms or group which draws an electron away from the carbon are said to have a minus I effect, or it is called minus inductive effect. So these are two kinds of an effect, that is positive inductive effect and negative inductive effect. So here the group which takes away an electron from an carbon, for an example, see this fluorine, chlorine, bromine, iodine, OH, NO2 and phenyl. So these are some groups which removes away an electron from an carbon, and which due to removal of an electron, or which draws the electron from an carbon. So this group are said to be a negative inductive effecting group. And there is one more, that is said to be those atoms which, or groups which lose the electron towards the carbon, are said to have a positive inductive effect. So these are some examples showing a positive inductive effect. So it is a tertiary carbon, secondary carbon, then ethyl, and then methyl, and out of which a tertiary alkyl group exert greater positive inductive effect than secondary, and list it is in primary. So this, it will be higher, second one will be this, third one will be this, and fourth it is in methyl one. And remember that why it happens so. If it is a structure of this tertiary butyl, and see this CH3 and this CH3. So here there are three carbons, there are three methyl groups, and this, it will exert an effect on a carbon. So they are losing the electrons towards the carbon, but they don't withdraw the electrons. So it is completely opposite to a negative inductive effect, and that is why it is said to be a positive inductive effect, because it gives an electron towards the carbon. This arrow, it is showing that it exerts an higher effect. And now if it is a secondary carbon, instead of this, here it is hydrogen and there it is CH3. So there are two CH3s in this structure, and they will exert the effect on the carbon, and it will donate the electron towards the carbon. But here are three groups of an methyl which exerts more effect, and compared to that, so this exerts more effect. So and after that, if it is only an primary one, so primary one will exert an less effect. So hydrogen, it is also it is losing the electron towards the carbon, but it is not so potential as compared to an methyl one. Methyl one, it is more potential compared to an hydrogen. So this was about a concept of an inductive effect. Hope you understood it. If you are having any doubt, you can comment me in the comment box. I will surely solve your doubt.